In this video, we are going to discuss about the time varying fields, which is related to Faraday's law. On the completion of this topic, students will be able to understand the two new concepts which we are relating to the electric field produced by changing the magnetic field, which we call it as Faraday's law. And next, they can also able to understand the properties of the magnetic field which is produced by the changing electric field. So, in this Faraday's law, so in this law, static magnetic field that cannot produce any current flow, but when there is a time varying field, this electromotive force, which we call it as EMF, induces some current in this closed path or the circuit. So this electromotive force is nothing but the voltage which is induced from the changing the magnetic field. And here we can write this Faraday's laws is equal to minus n d pi by dt in volts. Here if you are assuming the number that is single turn circuit, means that we can take it as this n value was 1, so that we can write this equation as E is equal to minus d pi by dt in volts. And also here, if you are considering the Faraday's law, the induced EMF which we are taking is a scalar quantity, so that we can measure in the volts, so that we can write it as E is equal to integral of E dot dl, and also the magnetic flux which is passing through the specified area, that we call it as pi, is equal to integral of B vector dot ds vector. And here this magnetic flux which is passing through this specified area, which we write it as E is equal to integral of E vector dot dl vector. If you are taking this term as differentiation, then we can write it as minus d by dt of integral of B vector dot ds vector. So here we are applying the two conditions for the induced EMF, which is first one is the closed circuit in which this electromotive force is induced here will be very stable, so that the magnetic flux which can be varying with the time, and that from this we can clearly say that is magnetic flux index density is only the quantity which is varying in time. And also here we are using the relationship by changing the coordinates as well as the time, so that we are writing this equation as E is equal to integral of E vector dot dl vector, which is nothing but minus d by dt of B vector dot ds vector. And these are the two conditions. First one is it is stationary, and from that we can say that it is which changes in varying the quantity of the time. And also by using the partial derivative we can find out the relationship of this B vector, that is we can write it as integral of E vector dot dl vector is equal to minus integral of dou B vector by dou t dot ds vector. So from this relation we can write in the cross product, which is nothing but closed integral of, that is del cross E vector dot ds vector is equal to minus dou B vector by dou t into ds vector, which we can write it as del cross E vector dot ds vector is equal to minus dB vector by dt into ds vector. So hence from this equation we can write it as, we can cancel the ds, and finally we will getting as del cross E vector is equal to dou B vector divided by dou t vector. Then second one, that is magnetic field we are setting as stationary, so that constant not varying with the time, while the closed circuit which we are relating will give the relative motion between these two forces. So this action we are taking similar to the generator action, and hence this induced EMF we can call it as motional EMF, or we can call it as generational EMF, since this magnetic field is stationary and it is not varying with this time. Then this we can write it as F is equal to QV vector cross B vector. So from that we can apply the equation, that is motivational electron field intensity we can define, that is force per unit charge, so that EM is equal to E by Q, which we can write it as B vector cross V vector. So from that induced EMF we can write it as, that is integral of E vector dot dl vector is equal to closed integral of V vector cross B vector dot dl vector. So from this equation, which represents the total electromotive force which is induced in this field when the conductor is moving by the uniform constant magnetic field, that equation we are writing as E vector dot dl vector is equal to minus of integral dou B vector by dou t dot ds vector plus closed integral of V vector cross B vector dot dl vector. And the quiz questions That is, first one is, for the time varying currents, the field or waves will be electromagnetic. The induced voltage will oppose the flux produced by it. State true or false. That is true. Thank you.